Good morning friends. Today we will discuss about the MOSFET, that is metal oxide semiconductor FET, and it is also called as insulated gate field effect due to this SiO2, that is this one is acting as a insulator. Okay, so already we know that the MOSFET can be divided into two forms, that is enhancement mode as well as depletion mode MOSFET. That enhancement mode in short form is represented E MOSFET, and for depletion it is represented as a D MOSFET. Okay, now see, this one is your basic structure of your how your MOSFET look like. Okay, as already we know that it is having three terminals, that is your the first part from the left, that is it will be having one notch here. Okay, that will be a front view. Okay, the first part is the first leg is known as your source, the middle leg is known as your drain, and the third leg is known as your gate, and it is been fixed source, drain and gate. Okay, next, so this one is the first will go through your E MOSFET, that is your enhancement mode MOSFET. Okay, so this one is the basic structure where we will be having p-type substrate. When the impurities or the high impurities of diffusion take place, then you will be forming a source and drain regions, and for the gate regions you will be adding through the polysilicon. And this one is the structure for the basic or the constant structure. It is known as your SiO2, that is your silicon dioxide, and this one is acting as your insulator. Okay, now how this basic structure is formed, just for your reference. First we will be having a p-type substrate or the semiconductor material. Okay, next when we add up high impurities, so by using the diffusion process we will just adding up for your high impurities of n impurities, so that will be forming your source and drain region. Okay, next it will be light by your SiO2 over both p substrate as well as your n substrate, and this one is acting as your insulator. Okay, next, so source and drain is over. Next we will form the gate region. So this gate region is formed by using the polysilicon. Okay, so this one is the basic structure, that is p substrate will take, n impurities will be adding, highly doped n impurities will be added to get the source and drain regions, and this will be right. Okay, next for the connection purpose what we'll do is we'll just etch the unwanted materials. Etching means removing the unwanted materials. Okay, and then filling with the metal. Okay, just for the connection purpose we'll just take this with the metal. So this one is acting as my source, drain and gate. Okay, so this one is the basic structure what it will be looking. So this one is the basic structure how it will be formed. Okay, next what? Okay, so this one is just the basic. So now what we'll do is we just apply the voltage source between the source and the terminal with the drain, source to drain. So we'll just apply the source to drain, that minus plus negative terminal as well as the positive terminal. Okay, so the two diodes are being formed from this to source to S and plus to D, that is from the, so this one is the reverse biased diode, and this one is your forward biased diode. Okay, so there will be a flow of, since it is a reverse bias, there will be a flow of current from drain to source. Okay, but initially it will not be having any, since only the voltage source is given to source to drain, there will be no flow of electrons between the drain to source. Okay, so what we'll do is we'll just apply the voltage source between the gate, that is the VGS, to the source, minus plus, and it will be just variable, will be just taking. Okay, when the voltage source is applied between the gate and the source. Okay, what will happen next is, now the channel, the electrons or whatever it is in a p substrate will all gather together here. Okay, so there will be a flow of electrons between drain to source. Okay, so and this will be attracted here due to this gate region. Okay, so there will be a flow of, when the voltage source is applied between this VGS, then there will be a flow of electrons between drain to source. Okay, and this one part is known as the induced N channel or induced channel, that is all the electrons are being gathered here and there will be flow of electrons. As the voltage polarity increases, the drain, the current flow of direction also will be just increase. Okay, see here. Now initially, so this one if I take, Okay, initially if it take ID, and next this one will be my VDS. Then at the 1 volt it will be just when VGS is equal to 1 volt, so this will be my VGS is equal to 3 volts. So in this fashion, as the voltage increases, the flow of current will also be going on increasing. Okay, so this one is the structure what we people will be just getting. Okay, so in this fashion also we can just represent, or in this fashion also we can just represent the voltage sources. Okay, next, first what will p-type semiconductor substrate will be taken. Next, highly doped impurities will be just added for this structure, okay, to form the source and drain region. Next, oxide load is placed and it is acting as a covers the entire, so it is just for the base structure. Next, gate region is formed by adding the polysilicon. Next, for the operation, what we will be doing is, as DC voltage is been applied between source negative and the positive terminal, okay, the PN junction is formed, and the positive terminal it is a reverse biased, and from this path it is known as the reverse bias, as it is already explained. Okay, no significant current will be flowing from drain to source, but tiny current flow due to source will be where the minority carriers. No channel is formed between the drain and source. Okay, with before the connection from source to drain, there will be no flow of connection. Okay, when the VGS is being given, at that time only the voltage will be just applied to the gate terminal. Next, the minority free channel formed to form the channel N. Okay, is next the accumulated here. The accumulated electron is totally depend upon what is the how much the gate voltage is being varied. Okay, next the width of the N channel depends on voltage applied at gate terminal. More than the applied, greater the width of the channel. Okay, and this part is known as your induced channel. Where is the flow of electrons will be there, that one is known as your induced channel. And the last one is, this one is known as your enhancement type MOSFET. If we are connecting a positive terminal to the gate and negative terminal to the source, then it is known as your enhancement type, this one. Okay, and this one is the characteristic graph of a N channel E MOSFET, that is the enhancement mode. As the voltage is increases, the current also being increased. Okay, next we'll just go through your depletion type MOSFET, that is your D MOSFET. The connection is all same as what you people have done in a enhancement mode MOSFET. Only the voltage source is being changed. There the gate terminal was being connected with the positive terminal. Here it is been changed to a negative terminal, and the source is with the positive terminal. Only we are talking about only the VGS. Okay, and the VDS will be same, that is the -2 plus, and all the characteristics have been, that is the p-type substrate is been taken, so the diffusion is being added up, okay, with the high impurities to form the source and drain regions. Okay, next, for the connection purpose, it all the etching process is been taking place, and it is filled with the metal for the connection, so we form the source and drain regions. Okay, in the same fashion, for the gate region, the polysilicon will be added up. Once again, it is just gone for the etching process, and the melt is filled with the metals to form the connections. Okay, so it only the thing is what the changes from depletion to enhancement mode is, or enhancement to mode is, only the positive terminal has been changed to negative and negative to in a VGS. Okay, next, the flow of corrector. So as it has been changed to this, the flow of correction will be formed from source to drain. Okay, and here all the majority carriers are being just collected here. As we go on decreasing the VGS voltage, that is the -2 plus, that is -1 -2 like this, then the holes will be just accumulated here, and the flow of direction will be what, from source to drain. Okay, and this part is known as the depleted region, where all the will be just accumulated, and this part is known as the depleted channel. Okay, next, see here, Next, here the region below the source to drain. So with the current can flow. If negative voltage is applied from gate to source, negative charge on the gate induces or equal amount of positive charge holes on the oxide layer. Okay, as I already told that when the positive source, the gate negative voltage has been applied towards the goals and it is going on decrease, then what will happen is all the holes with the majority coils are accumulated here at the channel. Okay. Next, this results in recombination of holes with electrons in the channel and reduce the number of free electrons available. Okay, next, as VGS is applied more negative, drain current reduces current ID. If positive potential is applied instead negative, the device acts as an okay. As we go on increasing the negative voltage, that is VGS is -1, -2, the current is be just going on reducing. Okay, see VGS is equal to 0 volts, it's in a constant. Next, VGS is -1, it is still reduced. If you just VGS -2, the current is also reduced. Okay, if you just go on in increasing the VGS value, that is -2, -3, -4, then the current also will be just reduced. Okay, so now this is the important part in this means we will be just forming both enhancement as well as depletion region. So at the VGS is equal to 0, what will happening is, so it will be in a constant, and above volt is known as the enhancement mode, and VGS will be, if we are giving a negative voltage, then it is known as your depletion type. Okay, so this depletion type MOSFET can be obtained for both in a depletion and enhancement mode. Okay, I'll just go through the symbol of, if the flow direction of the electrons is inside, then it is known as your N channel is MOSFET, and if the flow direction is outside, then it is known as your enhancement mode P channel MOSFET. Okay, so already we know that if the flow direction towards the gate is, then it is the N channel. If it is outside from gate terminal, then it is known as your P channel. Okay, now we'll just solve some of the problems. Okay, just so it is same as your what the problem we have calculated in FET. Okay, just for a D MOSFET, ID is equal to what, 10 milliamps at VGS is equal to -1 volt, and determine VP at IDS is equal to, also all these are the given values, and already we know that formula that ID is equal to IDSS into 1 minus VGS by VP whole square, and this one is the standard formula. We just introduce the whatever the value, that is ID is equal to 10 minus IDS is 15 milliamps, 1 minus, and VGS is equal to what, -1 volt. So we should calculate for the VP. So VP what we will be getting is minus 4.45 volts after calculation. Okay, next, and this one is to next for a D MOSFET, IDS is equal to what, the same thing, 10 milliamps, and VP is equal to -8 volts. The first what it should be saying is this an N channel or a P channel D MOSFET? Okay, next they calculate the ID for VGS is equal to -3 volts, and at ID is equal to VGS is equal to +3 volts. Okay, the first thing what you should determine whether it's a N channel or a P channel. Okay, so this N channel or a P channel depend upon the VP value. If VP value is negative, then it is a N channel. If the VP value is a positive, then it is a P channel. So in this problem, VP is what, -8. So what they are given is, the solution is the given D MOSFET has a negative terminal, that therefore it is a N channel D MOSFET. Okay, and the next part is what, at VGS is equal to what, -3 volt, we should calculate for this ID. So already with the same formula, that is ID is equal to IDS is into 1 minus VGS by VP. Okay, just put the values and get the value for your ID. So at ID is equal to at VGS is -3 volts, the ID what we are getting is 3.91 milliamp, and VGS is +3 volts, we will be getting it as 18.98 milliamp.